Assalamualaikum and a very good day. So now we go to the second part of the review of the matrices, which is operation of matrices. In this topic, you will cover matrix addition and subtraction, scalar multiplication, and matrix multiplication. In fact, you have learned this one before this, so this is just a review topic. We go first to the operation of matrices. So this is the concept how we can add, subtract, and also multiply two matrices. If let's say we have here these two matrices with the elements A, B, C, and D plus this another matrices. So when we add this, we just add the element. Means that A plus E, B plus F, C plus G, D plus H. Then we will got this kind of matrix. And then when we have subtraction here, we just subtract the element for each row and each column. In this case, we will have A minus E, B minus F, C minus G, and D minus H. And for matrix multiplication, we need to multiply each row by each column. If you have this kind of matrix, how to do that? In this case, you can use this concept, which is we have here, for example, A, B, C, D. I can write in terms of this one, E, F, G, H. And then when I want to multiply these two of matrix, I just make a line, this as a row, this one a column, because we need to multiply each row by each column. So in this case, this A multiplied by this E will be plus with B multiplied by this G. So we'll got this element. Means that we will have here A, E plus B, G. And then for here, this A times F plus B times H. So we will have AF plus BH. The next element, C, E, this C times this E plus D times G. We will got this element. And the last one, C times F plus D times H. We got this element. So here CE plus DG, and here the last element CF plus D. Then we go to the addition and subtraction of the matrix. We have the concept here. Two matrices A and B of the same order. What does it mean by same order here? Means that it has the same dimension. We can add or subtract by adding, subtracting the corresponding elements of A and B. Means that this is like the first concept and the second concept that you have learned in the previous slide. From here, we come up with the theorem of properties of the matrix. So here we have commutative law and also associative law. For commutative law, A plus B equal to B plus A. Means that here, doesn't matter the position of A and B. When you add two matrices, it is same with the another, we change the position of the matrix, which is B plus A. For associative law, here A plus B, A plus, if you solve this one first, you plus with this A, it is same as you solve this one, A plus B first, and then you plus with C. This one we call it associative law of the matrix. Let's do this example. Let's say we have here a matrix A equal to 9, negative 1, 2, negative 6, 0, 5, 8, negative 4, and 9 as the element. This matrix you want to add with this B. Okay, is it possible to add this matrix? So this one, it is not possible, because here for A we have dimension 3 times 3, but for B we have dimension 3 times 2. Means that it is not the same order. For A plus C, yes, it is possible to add these two matrices, because for this one, A is 3 times 3 and B and C also 3 times 3. So how to add these matrices? For B, we will have here 9 plus negative 1. Means that we just add the elements at the same row and same column. And then negative 1 plus 1, 2 plus minus 5, and then negative 6 plus 6, 0 plus negative 5, the element for A, 5, plus negative 2 for C, and then 8 plus 7, 1 plus minus 4, 9 plus 2. So when we solve this one, we've got the answer 8, 0, negative 3, 0, negative 5, 3, 15, negative 3, and also 11. So this is the answer for A plus C. For C, C minus A. Now we have for C 3 times 3 matrix and A also 3 times 3. So we can subtract these two matrices. We will have here C minus A, the element for C negative 1, minus 9, 1 minus negative 1, negative 5 minus 2. And then the next row, 6 minus negative 6, negative 5 minus 0, negative 2 minus 5, 7 minus 8, 1 minus negative 4, and then 2 minus 9. In this case, we will have here negative 10, 2, and then negative 5 minus 2, we have negative 7, here 12, negative 5, negative 7, negative 1, 5, and then 2 minus 9, negative 7. So this is the answer for C minus A. For D, is it possible for us to do this? So we check our C, we have 3 times 3, but B, we have here 3 times 2, and then A is 3 times 3. So this one, it is impossible for us to add these two matrices, means that we cannot solve for this. So this one, it is not possible for us to solve this equation. Next, we go to this example 2. Given the matrices A, B, and C, find the following matrices if exist. We check now for A, we have here dimension 2 times 3. B dimension 2 times 3. But C, it is 2 times 2. For A, we need to solve for A minus B. So in this case, we have A element 4 minus 3. And then the next element 2 minus 9. 6 minus 0. 1 minus 4. 3 minus negative 1. Negative 7 minus 8. So we'll have here 1, negative 7, 6, negative 3, 4, negative 15. So it is possible for us to solve for A, which is this one is A minus B. But for B, B minus C, B is 2 times 3, but C is 2 times 2. So dimension is not equal, means that we cannot solve for this B. And then we go to this example. Now we go to this example 3. Suppose we have these three matrices. We need to find the value of P, Q, and R if E plus P equal to A. In this case, our P, Q, and R are the elements of the matrices. So here for this case, D plus P, we can write it equal to E plus 3, negative 7 plus 9, Q plus 0, and then R plus 4, 4 plus negative 1, then negative 15 plus 8, which is equal to P plus 3, 9 minus 7 is 2, Q, R plus 4, 4 minus 1 is 3, negative 15 plus 8 is negative 7. When we solve for this one, we know from the question D plus P equal to A means that here this matrix which is P plus 3, 2, Q, R plus 4, and then 3, negative 7, it should be equal to A. That is 4, 2, 6, 1, 3, negative 7. You have learned about equal matrices in review matrix of part 1. So in this case, equal matrices means that the elements and also dimension are same. Here, the element for the first column and the first row same with the first element of a matrix. Now we can see that our P plus 3 equal to 4. So P equal to 4 minus 3, which is equal to 1. And then Q here equal to this 6, means that directly we can get Q equal to 6, and then R plus 4 equal to 1. So that here R plus 4 equal to 1. You can solve here, you will got R equal to 1 minus 4, which is equal to negative 3. Means that we got here our P is 1, Q is 6, and R is negative 3. Next, we go to another concept of the matrices, which is scalar multiplication. For a matrix A and you have a real number K, what does it mean by real number K? It is actually just a value, numbers. The matrix KA means that here this real number multiplied by this A is obtained by multiplying each element in A by K. So if we have here A equal to A, B, C, and D elements, if this K times this A will got here, this K will times with each element of the matrix. We'll got here KA, KB, KC, and KD. In this case, we have the properties of scalar multiplication theorem, that is distributive law and also associative law. For distributive law, if K is times with A plus or minus B, means that you need to multiply each matrix with this case. We'll got here KA plus minus KB. And if have another scalar H plus minus K, which is times a matrix here, so we'll got here H, which is scalar times matrix A, plus minus scalar K times matrix A. And another law is associative law. For this law, if we have H and K as scalar, where we solve first for this bracket K times this matrix, and then we multiply with this scalar, it is same as you multiply the scalar first and then you times this scalar with this matrix. Let's go to this example 4. Now we have A, B, and C matrix. So find the following matrices where possible. In this case, for A, 3A minus 2B. So here we have for A matrix 3, that is with times A minus 2 times B. We know that this one is 3 by 3 dimension. But B here is 3 times 2 dimension. So for this case, it is not possible for us to solve because we have the different dimension of the matrix. For this subtraction concept, the matrix should be same dimension. If we go to B, which is negative 5 times A matrix, means that this is a scalar times A matrix. We got here negative 5 times 9, negative 1, 2, negative 6, 0, 5, 8, negative 4, and 9. When we solve this one, we'll got negative 45, 5, negative 10, 30, 0, negative 25, negative 5 times 8, we got negative 40, 20, and the last one negative 45. So this is the answer for B. Then we want to solve for C. C, if you see here, 5B minus half A. In this case, B is 3 times 2 dimension, but A is 3 times 3 dimension. So in this case, it is impossible for us to subtract these two matrices because subtraction of the matrix we need to based on the same dimension of the matrices.